Well, maps are everywhere. When you are in a big city and you want to find yourself in the between this big traffic and buildings, you often use different gear applications. We have examples of maps and atlases of the world, of particular countries, and road maps, statistical maps you can see here, and different natural phenomena on a map. Because, in my opinion, and many scientists think that more than 80% of our experience we get by our eyes. And we see something and we get information quickly. And that is why maps are very useful, because these documents can give us huge amount information in one moment. What is it, cartography? Cartography is a discipline dealing with the conception, production, dissemination, and study of maps.
Okay.
Some scientists argue that every map is a kind of text, and every map has its own message that gives you or anybody who wants to read the map information that put in it by its creator. We can also deal with different phenomena, not only natural phenomena, but also social phenomena. Here you can see a screenshot from American corporation SRI about household income, where rich people lives, where poor people lives, and you can see such example of a map. Cartography is considered as a science of preparing all types of maps and charts, and includes every operation from original survey to final printing of maps. This is example of United Nations text. So the maps production is a process because first of all we should capture data, and then we should to analyze this data, and then we have different techniques, for example computer techniques, and also we should have a concept, an idea of what should we present by a map, and then we structurize all this data and put in on map. I'm sure that you will have an opportunity to make your own maps during our course, and I will give you links. I will give you some links to open software, and we will try to create own maps ourselves with you. All the maps has a different design. Nowadays, most of maps are made by computer software. On the other hand, ancient maps, which has been made by artists, by cartographers of ancient times, these maps also are very beautiful and colorful, and we can we should we can have pleasure to have a look on these maps. Cartography is the art, science, and technology of making maps together with their study as scientific documents and works of art. This is cited by Mainen, 1973, and I should agree with him, because all the maps I have seen during my life, if these maps are made with attitude, with good attitude, with by people who like this work, all the maps can be named kind of art, because all maps are beautiful. Spatial data. Scientists say that maybe 80% of all data around us have spatial component, have spatial coordinates, and it is possible to put these data on a map. Here's the definition of the spatial data. It's a data with a spatial component relating to a specific place on our planet, Earth. Looking on landscape, you can probably see that all the spatial data is very different. We know that our planet has many features, many processes, many different objects that And these objects are very interesting for us to understand their nature, their genesis, their how all these objects interact among them. And in GIS software and in cartography, we can imagine all the data like kind of layers or above the Earth's surface, and every layer represents some kind of natural or social phenomena, and that is why in GIS software we can use these term layers to understand or to create model of a very sophisticated and very complex world around us. Another definition: cartography, the science of the reflection of phenomena of nature and society on geographical maps and other cartographic works, about the properties of these images, methods of their creation and use. In the broader interpretation, cartography includes technology and production activities, and also, of course, science and art. And we will speak about cartography in these three dimensions. Speaking about technologies, nowadays these spatial technologies are developing rapidly. Digital cameras, face scanners, radar equipment, and of course global positioning systems. All these techniques give us huge amount of data, and nowadays the amount of data from space satellites, this amount is very enormous, and they put this data on servers free, and everybody can take this data and make their own maps. So the cartography nowadays is a part of a great industry. And you are absolutely true that mining and different kinds of nature exploitation, such as forestry and agriculture activities and mining and fishing, and all kind of activities need spatial data to improve these activities. So cartography is a part of a huge interdisciplinary industry, where we capture and store and analyze and distribute spatial data. Understanding cartography and using the knowledge given to you, cartography science, digital arts, and computer science are essential for working as a cartographer. You will need to have some experience in computer science. This is because you would need to know how to operate computers, scanners, plotters, and how to run different software for mapping and data analysis. Economic factors is also very interesting. Here you can see this, not my slide, I take it from free open sources. It's about Canada. And you can see that people who work with spatial data also have good salaries. Here you can see a link on these presentations. Cartography is related to study of geography because cartography requires using maps, GPS, and understand geographical laws and conceptions, because probably you can think that it's very easy to take a data and put it on a map. However, not always the map will be good enough to users, because you should have some knowledge in geography to understand how all these spatial objects operate, what are relations among these objects, and of course you have opportunity to acquire knowledge about ancient maps and modern maps. There are huge amount of maps on the net, and you can explore these maps not only as person, but as professional and as one who have little experience in map creation and map production and map making technologies. Well, it's my own translation of our traditional view on cartography that lays on the intersection of different science and technology fields. Well, let's move on and try to understand all these peculiarities of cartography. Cartography has connections with geodesy because we have all the geodetic data is one of the most important part of any map, because we have projection and understanding the mathematical law, how can we put all the features from the round Earth's surface on a flat map. And mathematics gives us understanding how to do this. Well, Earth sciences, it's of course geography, geology, and natural conservation, and all scientific disciplines which deal with Earth observation, Earth features explanation, understanding, all land features and geological structures that are under the Earth's surface. Another one big branch of science and technology is remote sensing. In future lectures, I will give you a vision of all these different kind of space satellites and data that you can get from different web portals. All this remote sensing data is very useful because it's very cheap. Because we should not go down to the jungle or forest or seashore. We need not be there ourselves. We only need to have access to satellites, and these satellites can give you data with very good resolution. For example, 30 centimeters in 1 pixel of the image, and also aircrafts and helicopters and all the equipment give us enormous amount of data that can be put on a map. Well, some scientists think that cartography is a kind of art. Of course, we have we like to look at different kind of art because we think that art is beautiful, and you can agree with me that maps also very beautiful because they are colorful, and we have contrast, composition, design features, and all the features that you can also see in any book or any booklet. And every map, of course, give us not only scientific data, and also gives us image of territory. And they say that in ancient Europe, maybe in the Middle Ages, all the kings have in their palaces rooms with a lot of maps. And they like to go in and watch these maps and think about their kingdoms and about war and peace, etc. Well, another significant feature is land use. We live in a society when private privacy exists and every part of land has its owner, and so all the features, all the issues connected with land use and land property is very, very important, because many wars and many conflicts in the history and nowadays are has this land use component. So people wants to have access to production sources, and land territory is a main resource for development. However, such countries as Japan, for example, has no much territory on these islands, but they use this land very effectively. On the other hand, we can find examples of countries that are poor, maybe because they don't use their land very good. Well, mathematics, we should mention the mathematics as a huge approach all over the scientific research in different sciences. In social sciences, in natural sciences, in physics, in astronomy, and also in cartography. We have huge influence of mathematical methods. Because there are many natural and social features that has no and we have no clear understanding of how features interact, and mathematics can help us to understand relations between different objects and processes in the geosystem, in the natural environment, and in the social environment, etc. So also we can use, we can understand strong relations between social sciences and cartography, because cartography has also there are many cartographical applications on business data, on management data, and we can also explore and explain different features, for example, political elections and religious particulars of territory, demography, sociology, economics, and etc. And if we put all these social sciences data on a map, we can explain and understand much more. Much more. And the last one is cartography has good connections, good relations with cadastral and real estate activities. I give you examples and links on Ukrainian cadastral map, and you can see all these land parcels and even more numbers of these parcels, and you can and apply for owner of this land parcel, and all this work concerning with real estate need geospatial data to calculate, for example, an area of land parcel and how one should pay for to the government for use this part of land. Here you can see the link on mapping and spatial analysis in schools in the United States. I will give you some examples of how these spatial data, in my opinion, it gives wider worldview to students, and students in the school, in university, and elsewhere. You can follow the link and look these examples yourself. Well, this spatial data gives us understanding of how our world operates. Our world operates. As I have said, we have a very complex environment. Scientists try to explain this environment as a huge network of different transport infrastructure, natural rivers, forests, and atmosphere circulation, and all these different features, geographical features, and we should manage this environment. And the main goal of every government to understand how to operate with all these features. And you can see in the picture that modern approach says that we can create different products, for example, ortho mapping, or to put all these features on the flat surface. Reality mapping, it means three-dimensional mapping and giving different features in the 3D coordinates. And then we should analyze all this data and then visualize and make decisions on how to operate with all these other features. In this picture, you can see one approach that gives you understanding of how GIS and cartography can be explained. First of all, GIS is an analytical technique that help us to work with data, that gives us tools to operate with data. On the other hand, cartography is more close to synthesis and design. While GIS make analysis, cartography make synthesis and design, and cartography give us understanding how to put all the data on a map and how to create a beautiful presentation, and also how to explain all these features on the Earth's surface. However, this understanding have some faults because nowadays any map could not be produced without data, and GIS and cartography begin to get closer and closer. And nowadays we should speak about geosciences, and every cartographer should have experience in GIS software, because most of maps nowadays is developing with computers. Well, GIS software. GIS, we should give such explanation that GIS is the tool we use to capture, store, process, analyze, and visualize spatial information. This software and even more GIS science, you can find on the net a huge amount of publications about GIS science. It's kind of science of where you are, where are you going, what direction do you prefer, and what environment exists around you, and we like to use all this software in our smartphones to understand where we are in a city. However, this is a very simple possibility to use a map only for orientation and understanding your own place. Cartography gives much more tools to understand relations between natural deposits and natural contaminations and all these different features in in variety of people activities. Good example of understanding the power of maps is national atlases. I give you just a second a link to nationals. National Atlas of Ukraine, for example. Here you can see it's a brief representation of paperback atlas, and they put a few maps on a map. Here you can see, you can link on this atlas. Also, you can try to access National Atlas of Canada, for example, and all these you can see different subjects about minerals and mining, energy, climate, forests, etc. Well, theoretical conceptions. Sorry. Let's go. We have several theoretical conceptions of cartography in our post-Soviet science. First of all, cognitive or model cognitive concept that explains, that considers cartography as a science of cognition of reality through cartographic telling, and the map itself as a model of reality. This conception was the main in Soviet Union and post-Soviet countries, and it's a point of view that give us understanding that every map is a model, and you can agree with this point of view. Another point of view is the communicative concept. And here we should say about communication. Cartography is considered to be the science of the transfer of spatial information, and the map a channel of information and of communication. For example, you are from Africa, from another country, and now we use English language as a communication tool between us to understand some information. The map also is a kind of text, and another concept, it's a concept of cartosemiotics or linguistic concept, considers cartography as a science of the language of the map, and the map itself as a special text composed using conventional signs written in the language of the map. There are a big amount of big amount of cartosemiotics conception publications on the net, and I think that this point of view also can exist because these scientists are speaking about map rules and how should we make map properly, and all these analogs with our language, like a syntaxis and pragmatics aspect of map use, etc. And I will show you examples of interesting ideas of these scientists. In the 1980s, an integrated information concept was formed. According to this concept, cartography is considered as a science of information and cartography modeling and knowledge of geosystems, closely linking it with geoinformatics, earth sciences, and other spatial data techniques. This geoinformation concept in my opinion can be final result of convergation of these earlier conceptions, and it has all these ideas inside it. How do you best model reality? Well, you can see it's a part of maybe United States West Coast. You can see all these small buildings and streets and hills and forests from the space. However, it's very beautiful picture, but it has no much useful information because we don't know the names of the streets, and we don't know what street is much wider and most important in the region, and all the information about this city or town. On the other hand, a map gives us simplified information on the environment. However, we can read this map and understand all the streets and geographic features names, Rimrock Canyon and Anita Street, Cariota Drive, etc. Also, we can understand the land surface relief and what parts of land is higher, and these lines, contour lines, you can even more measure this map and understand Hayes difference between 2 points of the territory. So to summarize this, I should mention that we use different kind of maps for different purposes. Cartography and mapping gives us a huge amount of examples. We use cartography to display Earth, land, sea, outer space, planets. We have possibility to present our knowledge about different parts of space in different scales. Also, we have three main kind of maps. One kind is topographic maps. It's a kind of universal maps that show us all the spatial features on the territory: natural, environmental, social, transportation, housing, and so on. On the other hand, thematic maps gives us only one or two particular subjects, and however, these maps maybe give much more understanding of every particular subject. Here you can see the name of the map, the 6 months of drought in the American South. And this kind of maps use different artistic features, artistic techniques, color, lines, shadowing, and so on. And the next one kind of map is a special purpose map. For example, real estate map, or tourist map, or military map, or nautical chart. These maps are made particularly for special purpose, and this kind of map also these maps has different some peculiarities of creating and understanding. Another classification is a classification of maps depending on their scale. Small scale maps give us the whole world picture or view. Medium scale gives us continents and countries and regions of the world. And large scale maps gives us very good understanding of all features on the Earth, contour lines, and every feature in very good resolution. And here we are going to the end of our today presentation. I would like to give you some examples of maps. This is a map of Switzerland, mountains and glaciers. I take it from SRICOM site, but these maps have been made by Edward Imhoff. It's a famous cartographer from Switzerland. And now I will give you a link to the particular site. This site has relief shading, and you can find very beautiful examples of maps presenting relief and presentation of relief by different cartographers during the history of cartography. And here on the site you can see famous cartographers. Here Edward Imhoff was professor of cartography at Swiss Federal Institute of Technology in Zurich from 1925 until 1965. His fame extends far beyond the Institute of Technology, stems from his relief shading work on school maps and atlases. You probably know that Switzerland is a country in the middle of Europe, and almost all the territory of the country covered by mountains. It's huge, beautiful mountains, and so you can read and see examples of these really beautiful maps that represent all the peculiarities and all the features in very, very beautiful way. To say more, it was manual work. There were not computers in this time, so it's very, very interesting view on how to present land features. Another example is Nautical Charts. Nautical Charts. Here you can see the link. I will share it with you later. Nautical Charts is a special purpose map which explain all the features of any aquatory, and these numbers are the depths in meter below sea level, and all the aquatory was very good. On the other hand, land is presented much more not so good, because the main purpose of the maps is navigation features, navigation dangerous. Here you can see a ship that is a danger for another ships because it just sink down, and it is very dangerous for another ships. And different lights in the aquatory, etc. Here you can see example of topographic map. I'm not sure, but maybe this example of Norwegian map, Norway, yes, topographic map Norway. Hills, mountains, not very 2,000 meters, it's big mountains, and different industrial features and settlements, etc. Topographic map is an universal map because it shows all the features of every territory, and all these features we can compare all these features and understand what exactly is on this part of territory. Historically, topographic maps was the first kind of maps because, first of all, cartography, these topographic maps have been used for military purposes. And if you look on the net, search the net, all these ancient maps, first of all, have been used for military purposes and for real estate purposes. And then they began to create more wider different kinds of maps. Another example, it's also Switzerland. It's a digital elevation model which gives us understanding of elevation above sea level, and this picture is very beautiful. It's a kind of thematic map because we have only one feature to display, only relief heights, Here you can see elements, scale bar, and some info. Another example is a futuristic presentation of kind of social or economical features and probably connections between countries in 3D dimensional space. It's a kind of not simple map. However, modern software gives us possibilities to create different kind of maps